Welcome to another Explainer. Today, we are taking a look at a system that completely redefines how we think about artificial intelligence in a production environment. We're looking at Atlas. Now, I want to be super clear right off the bat. We are not talking about your standard, off-the-shelf AI orchestration layer here. What we've got is a highly defensive, state-aware, and production-ready compliance engine. Honestly, think of it kind of like a piece of high-end neon tech design. It's sleek, it's highly structured, glowing with precision, and just ruthlessly efficient in the dark. It is built to protect itself every bit as much as it's built to operate. It is, quite literally, an AI fortress.
Okay, let's dive into this and look at the blueprint of this neon-lit fortress. We're going to start from the ground up with the hybrid search engine, move into smart orchestration and state, check out how it delegates to subagents, and finally, arrive at the absolute ultimate line of defense, the egress firewall.
Starting us off, Section 1, the hybrid search engine.
You know, a lot of AI out there just relies on basic semantic matching, right? But Atlas goes way beyond that. It uses a dual pipeline retrieval architecture. Whenever a query hits the system's API/search endpoint, two massive operations trigger simultaneously, literally like two racing neon data streams. On one side, we have this deep conceptual AI understanding. That's the dense vector search, which is mapping hundreds of dimensions in the cloud. But on the exact same beat, an in-memory BM25 keyword search fires off for laser-focused exact word matching. So you've got deep comprehension racing right alongside precision speed.
Now, what's really interesting about this is how Atlas actually handles those two very different sets of search results. It synthesizes them using an algorithm called reciprocal rank fusion, or RRF. It basically takes the conceptual fuzzy results from the dense vector search, grabs the exact keyword hits from the keyword search, and calculates a combined RRF score to create a single, highly accurate ranking. It essentially gets the absolute best of both worlds, mathematically fusing them together.
So why does this RRF score matter so much? Well, because it's the fortress's first line of defense against hallucinations. The system actively monitors a set threshold for these RRF scores. If that combined score falls below the threshold, Atlas just flat out refuses to guess. Instead of hallucinating a plausible-sounding answer, which we all know AI loves to do, it triggers a strict citation directive. It strictly halts the process and redirects the user. The system would rather stop dead in its tracks than provide you with false information.
Moving deeper into the system, we enter Section 2, Smart Orchestration and State.
Think of this part as the glowing control room of our fortress. In the past, orchestrators were so weighed down by persistent context, they were constantly carrying around this massive backpack of files they might not even need, which often led to those endless, frustrating logic loops. But here, with the dynamic knowledge graph, Atlas has completely thrown that backpack away. Static files like agents.md and the full file tree manifest, they're completely gone. Instead, the orchestrator uses a tool called listdir to dynamically traverse directory paths only exactly as needed. This keeps the AI's mind pristine and hyper-focused solely on the active task at hand.
But hey, even the best systems hit errors, right? Here's how Atlas handles them without getting stuck in a rut. It uses a really clever 3-attempt retry loop in its usechat.ts file to mitigate retry blindness. Let's say an error occurs. Instead of the AI just blindly trying the exact same thing again and expecting a different result, a system alert is injected directly into the context. It essentially tells the AI, look, here is the exact error and here's exactly what you just tried that failed. Because this alert alters the input, the orchestrator is mathematically forced to abandon its stubborn mistakes. It literally cannot repeat the dead end. It has to generate a novel approach.
All right, now we reach Section 3, delegating to subagents.
The days of relying on a single, massive AI model trying to do absolutely everything, those are over. Workload routing in Atlas is no longer a monolith. It's a highly formalized hierarchy. Every single incoming text array is first evaluated by a super lightweight supervisor model. Think of this as a preliminary zero-shot intent pass. The supervisor doesn't actually solve the problem, it acts more like a neon-lit traffic cop. Based on really rigid definitions, it routes the workload to highly specific subagents. A general query, that gets sent over to the concierge persona. A complex compliance logic task, that gets routed straight to the policy design persona. Everything has its specific place.
Which brings us to Section 4, the final layer, the egress firewall. This is the exit door of the fortress. It features a totally air-gapped security model that protects the underlying infrastructure and all that proprietary logic before a single word ever reaches the user.
Literally, before any text flows to the client interface from the API/chat endpoint, it must pass through an air-gapped bouncer. The drafted response is piped directly through a local guardrail agent. If this bouncer detects any violation of the strict IP rules, like, say, orchestration details or internal calculation steps leaking, it immediately halts the stream and surfaces an ERR IP violation blocked protocol. Nothing unauthorized gets out, period.
And this brilliantly illustrates exactly how that bouncer thinks. We can look right under the hood at its actual system prompt. It is explicitly told, "You are the output egress firewall for Atlas. Your sole purpose is to evaluate drafted responses and determine if they contain proprietary intellectual property. It has one job, and it does it with absolute, unwavering authority. If the response violates a rule, it returns an error. If it's safe, it returns safe."
Let's really slow down for a second and step through the exact rule set it follows, because the contrast here is wild. Notice the dramatic difference between the block and allow directives. For compliance logic, it strictly blocks specific weights, scoring algorithms, and internal heuristic steps, but it allows the final compliance determination and public legal statutes to pass through. It entirely blocks any system prompts, persona instructions, or routing details. It blocks all infrastructure constraints. We're talking exact code snippets from the source workspace, database schemas, Gemini routing logic, all of it. And it completely blocks any third-party data, like internal API keys or Stripe webhooks. The underlying code and logic remain a total, impenetrable black box to the user.
Now, it is really important to clarify this evaluation directive. Because Atlas does not host sensitive, personally identifiable information, or PII, the firewall actually doesn't need to waste any computing power scanning for user data. Instead, it is 100% laser-focused on IP protection. It strictly targets prompt leakage, the exposure of any code-based structural details, and those highly proprietary compliance mapping algorithms.
So the crucial point you should take away from this is that this lockdown isn't just happening at the final text output stage. No, it's baked deep into the immutable role-based access control, or RBAC. Tool execution and external API triggers are aggressively secured by Firebase security rules. Every single subagent operates within strict service account boundaries. This means that the authorization context absolutely must be verified before any mutable request is returned. It is a complete and total lockdown of external triggers.
Which leaves us with this final thought to chew on. We've seen how Atlas builds an absolutely impenetrable fortress using hybrid search, smart orchestration, strict routing, and a relentless egress firewall. But honestly, it raises a much bigger question for the entire industry. If production AI must become a heavily guarded black box to protect its proprietary intellectual property, how do we balance that necessary security with the user's very real desire for transparency? It's a fascinating challenge, and Atlas shows exactly where the battle lines are being drawn right now. Thank you so much for joining me for this explainer, and I really hope this provided a clear look at the true anatomy of modern AI security.